Bioengineering, Dr. Feng.
Ten years ago, I had a LASIK eye surgery, which improved my vision to 20/20. I can still maintain this vision until now. But another patient, Susan, suffered from significant vision loss. For her, having LASIK is the most regrettable decision in her life. Susan's case is not rare. Actually, 1 in every 200 LASIK patients develop a condition called post-LASIK ectasia. This condition causes your cornea to get thinner and bulge outward, leading to progressive astigmatism and ultimately vision loss. In order to detect early stage and post-LASIK ectasia, it's essential to develop a screening tool to identify patients at risk. However, the existing screening tools only focus on the structural information such as cornea's thickness and curvature. But in the early stage ectasia, those structures may appear completely normal. Research has suggested the mechanical properties of the cornea can serve as a more sensitive diagnostic marker. It's also believed that ectasia starts as a localized weakening. So if we can capture the mechanical changes within that tiny region, we can actually detect the early stage. Our hypothesis is this. If we can detect corneal ectasia at the early stage using a high-resolution clinical diagnostic device, then we can identify patients at risk and thus reduce post-LASIK ectasia. However, measuring the corneal stiffness is actually very challenging in a living patient. An existing device can only provide a single read of the stiffness across the entire cornea. So it doesn't have any spatial information. To address those challenges, our lab has developed an optical diagnostic device turned optical elastography. This device is capable of mapping the corneal stiffness with high spatial resolution. And the device consists of a small probe that can gently tap your cornea, generating vibrations that travel through soft and stiff tissues at different speeds. A computer then analyzes the differences and then generates a color-coded stiffness map, just like shown here. Our results have shown for the first time a remarkable stiffness gradient in healthy human cornea. And even more exciting, we have found that early stage ectasia actually presents a more distinct stiffness pattern as compared to the healthy normal controls. Our device holds promise for clinical diagnosis, enabling safer LASIK screening and helping Susan and her doctors alike to make a better decision about their eye surgery. Thank you.